We are now starting. Good evening to the auditorium and to the speakers. We see that we had already a very successful day that comes to an end, and we are now having the last Q&A sessions to talk about gallium nitride and the usage and the application areas. And I want to start encouraging you also to talk between both of you if you have subjects which you can raise. In general, one of the general questions I had during the day was about GaN versus SiC. What you see is the better solution, or what's the crossover area? Jeff, if you like to start talking a little bit about that.
Yeah, sure. Thank you. So I think it's a question that is coming back each time. Indeed, silicon carbide versus gallium nitride. Yeah, typically you see these comparison slides when where there is clearly a voltage gap beyond 650 volt, leading more to silicon carbide applications, below 650 more to gallium nitride applications. I think I would say it depends. It depends highly on the application. What we do see, so we are quite active also in aerospace and in space applications, where gallium nitride is a must. So fortunately, there in this specific case, you don't have a choice, since silicon carbide is not radiation hardened. It will be destroyed if it sees radiation opposed to gallium nitride. But that's then really application driven. What we do see is that typically lower voltage application beyond 650 volt, they can benefit quite well from gallium nitride. Beyond that, silicon carbide is more of a will be more dominating the market. So what we expect is that, especially in markets like EV and high power inverters, that silicon carbide will be leading. I think also in probably lower voltage EV, you have also the 100 volt and 200 volt gallium nitride applications, where we do see a big benefit in using gallium nitride versus silicon carbide. So it's clearly dominated by the voltage range that you need, either at your input or at your output of your converter.
Thank you. Ilya, what could you add to these statements?
Yeah, so basically I agree with Jeff. What I wanted to add is gallium nitride and silicon carbide are both great wide bandgap technologies, and each of them has their own advantages for different applications. For example, as Jeff said, silicon carbide offers advantages at high operating voltages. What I wanted to add is that silicon carbide also has some advantages in high temperature operations. We already have some commercially available. 200 C qualified for automotive. Gallium nitride, on the other hand, does show performance advantages across the board for the operational range that it is qualified at.
Yeah, I think Elijah, you mentioned indeed a key aspect of silicon carbide is indeed high temperature capability. Also, I think yeah, we are talking about differences, but I think we also need to talk about the similarities between gallium nitride and silicon carbide. So they're both wide bandgap, meaning both of them can potentially benefit from very high, very fast switching times. So potentially limiting the switching losses, especially for very high voltage and current ranges. But I think there's always a big dependency there, is that you need to have the right gate driver. And what we mean with the right gate driver is you want to keep typically the gate loop as small as possible, as short as possible. You also want to keep the bus voltage loop as short as possible. And I think especially in when we are going to high temperature, elevated temperature ranges, 200 degree plus, you start to become, you're somehow like with any design, you need to make trade-offs. But it starts to become very challenging to find a gate driver which can also operate at these elevated junction temperatures. Of course, what we now see typically in the market are silicon carbide power stages with an, let's say non-integrated gate drivers. Which then are somehow thermally also isolated from the silicon carbide, but still they suffer from poor cooling or poor heat evacuation, which then eventually even also leads to high operating temperature. So there are specific requirements for both for silicon carbide and gallium nitride. I think both of them need to be able to cope with the very high slew rates. I think for silicon carbide, even more than for gallium nitride, high temperature capability is a key aspect.
Gentlemen, we get the first question in, which will be addressed to you. When will VisIC ramp up their volume for electric vehicle applications? And what is the status of their GaN devices?
So of course, our plan is to ramp up the voltages with our customers. We have designs for, which are planned to be released in 2023, 2024, 2025, and accordingly we will ramp up the production. The status of our GaN devices is that we are releasing samples available for customers. We also plan to release new technology very soon. In parallel, we are also qualifying for the automotive ASIC 101 standards, planned to be next year.
Thank you, Elia. There is a general question addressed to me. The handouts of the recorded presentations will be available on my website, dodospower.com, by the end of the week. I think Friday, everybody could find all the recorded presentations and the recorded question and answer sessions. That answers the question from Francesco. Okay. At the moment, there is no more questions on. There is a thanks a lot from Francesco. Hopefully, not all the visitors are in the come together party area. That's what we had in a real event. Now, the next question is how do you see the GaN penetration in industrial applications?
Well,
Yeah,
please
yeah,
go ahead,
please.
Jeff.
Okay, thank you, Francesco. Thank you, Elijah. I'm sorry. What we are now seeing is like in many emerging technologies, I think we can still call gallium nitride emerging, same as silicon carbide. Is that there are more and more gallium nitride vendors available. More and more devices are available. What we do still see lacking is an offer of adequate gate drivers. So it always goes hand in hand. So you can only get the full benefit of your gallium nitride device if you have the right gate driver. I think that's where we are quite active in. So the adoption in industry, we do see requests from customers that are looking for specifically for gallium nitride gate drivers. We do have had some requests recently also for servo applications in robotics. So there is clearly a market request and a market drive towards adoption of these technologies, since you could potentially go to heat sinkless or even fanless power drivers for industrial application, which clearly offers a big benefit. But again, their dependency is with also the availability of the right GaN drivers. And one of the things that we do see is that many of these GaN drivers that are now on the market, they are lacking, for example, 100% duty cycle capability, which means integration of a charge pump, especially if you're going to high duty cycle driving, which is quite typical for industrial applications. What we also see lacking is typically the ability to do some kind of overcurrent or desaturation checking, as is quite common in silicon carbide, is still lacking for most of the GaN gate drivers. So adoption is coming, although I must say this is still emerging. Many of these industrial applications can still live with very low cost MOSFETs, and I think it's still a very cost sensitive market. But we do see the requests coming, and clearly we are also working on the next design-ins.
Yes, from our side, definitely we see gallium nitride penetration in the industrial market for years now. As you can see from my presentation, for example, for phone chargers, gallium nitride is pretty much becoming the norm. And industrial power supplies, computer power supplies are also starting to adopt gallium nitride because they see the efficiency benefits. And as Jeff said, the reduced requirements for cooling. And of course, as more players and enter the industrial market and offer compelling solutions, the market will adopt more and more these technologies, because I don't think anyone doubts the advantages right now.
Thank you. So we look for next questions, but it had become quite this moment. generated so many things. There is a question. Are major electro vehicle OEMs interested in GaN?
Definitely. Of course, I can't disclose the OEMs we're in various types of cooperations with, but definitely we see a lot of interest from gallium nitride. I think even in the latest Daimler investor conference, they specifically mentioned gallium nitride as their future technology. We see also a lot of interest from large tier 1 companies, and I think the latest press release from ZF also mentions that.
Thank you, Leah. The next question comes in, and do you believe in GaN for inverter applications for electro vehicle? If yes, in which time frame from now?
So definitely, personally, our company is specifically focused on this type of application, and we believe that gallium nitride can provide a very significant benefit for this. From the time frame, we are working with customers and for projects from 2023 onwards.
Okay. And the next question is, which power are you focusing on? I think that means what power range you are focusing on.
So we're focusing on the multi-kilowatt power range for automotive, for example, the onboard chargers. But from an inverter applications, these hundreds of kilowatts.
Thank you. I think the people are getting more ready to get their focus to the dinner time. Will we see GaN modules in inverters like in SiC is a question.
Definitely. Straightforward answer.
Okay.
Yeah, I also need to add to that. So I agree with you, Elijah. We are also quite active in monolithic integration of gallium nitride together with pre-driver circuitry. So yeah, except from getting the power device into yeah, let's say a power or a power module like you see very abundantly in silicon carbide. We also think that the full benefit will only come when there is full integration, so full monolithic integration of pre-driver, possibly also RF couplers, and maybe even the isolated power supply into a single monolithic die. So that's this is a tendency that it will not be for the year to come, and maybe not even for the 5 years to come. But this is certainly a trend that we see in research, and is also being pursued in some commercial companies like, for example, Navitas, EPC, which are starting to co-integrate pre-driver with their power stages, and then yeah, eventually this I think this will be the final trend where you see everything integrated into a single module.
The next question addresses the same subject. How about the reliability of full monolithic integration?
So from our company, this is a topic that we're not approaching. Currently, we see this trend in EMO devices. And so far, we have not seen any automotively qualified monolithic devices in the market for high voltage.
Okay. So back in my memory, a fully integrated semiconductor solution had always ended up in a higher reliability than a solution that uses more parts that need to be wired together by bond wires, which had always the problem to fail. The question to MinDCet, GaN IC using GaN SOI, can this be acceptable in power arena from a pricing standpoint?
Yeah, this clearly depends on the market. Huh? So I think if you're looking in high volume commercial applications, I doubt that this could ever compete with standard bulk CMOS or with DMOS devices. But we do see niche applications where this is really important and key differentiator. I touched in the very beginning, also touched that we do quite some work also for aerospace, so radiation hardened designs. I think especially in these markets, on one hand, integration is very important. Cost of the wafers is, let's say, second order importance. It's mainly reliability. The less components you have to integrate into a single package, the more reliable, the longer the lifetime. And so clearly for niche applications, this is acceptable. For high volume applications, I think there's still a way to go. But okay, there's always typically one key adopter, and then eventually the rest will follow if the volumes are also following. But I think we are not there yet for, let's say, an appealing cost perspective for GaN on SOI.
Thank you, Jeff. We're getting close to finalize our question and answer session. It was a very fruitful day for us. We had people from all around the world. We had Asia and we had California in one conference, which is not in a real conference possible, but virtual, we did it. And we did it quite nicely, I see. And I want to thank all the presenters of today and all the patient visitors who addressed the questions. And we look forward to better days, and I can only say stay healthy and look forward to next year when Corona may be solved by medical support of vaccine, and we can meet again in Munich in the airport hotel in the Hilton and have a conference in reality there. Now we will all probably turn around and have our dinner at home at our family's desk. Thank you again. And I think if there are no more questions there, we may stop the recording here and say goodbye for today. And for all the visitors and all the presenters, see you tomorrow again for the second day of the Wide Bandgap Power Conference. And again, everything will be recorded and available on my website by Friday, probably, for all the ones who want to see a specific presentation again or listen to a specific question and answer. So we finished that in cooperation with AspenCore, and we feel happy of being so successful in the fourth year without being held back by Corona. We do it just the way, virtually the best way we can. Thank you, and I will say bye-bye to everybody. Good night and have a good dinner time.
Thank you very much. Have a good day or evening.
Thank you, Bodo. Thank you, everybody. Bye.
Bye-bye.